Right, I just want to very briefly talk to you in a little bit more detail about the idea of projecting at an angle. So if you were to say hit a tennis ball with a racket, it would go up in the air, come to its greatest height and then come down. If you were to throw a ball at an angle, that would happen. Now, in the last video, in a set of examples, we looked at throwing something horizontally or projecting it horizontally. So the only difference now is that our angle of projection is not 0. So we're still projecting at a speed, whatever that may be. I've called it capital U here. And therefore this vector here, the velocity, will have a horizontal component coming to the right of capital U, that's whatever the speed is, multiplied by cos alpha. And a vertical component going up of capital U sine alpha. So that's the velocity that you initially project at. And it's always the speed times by cos alpha horizontally and the speed times by sine alpha vertically. So let's take a look at this here. In example 4, we have a particle being projected from a horizontal plane. That's what that means is like flat ground. Flat ground is a horizontal plane. So it's being projected at a speed of u, which is in this case is 40 meters per second, but at an angle alpha, where tan alpha is 3/4. So it gets thrown up like that, and it will come up in the air and down, and eventually it will land and hit the plane again. So that's your horizontal plane, that's the ground, for instance, there. And we've got this idea of the horizontal and vertical components of the initial velocity. Now I've called here the horizontal and vertical components ux and uy. So if our velocity u is 40 cos alpha and 40 sine alpha, the 40 cos alpha is ux and the 40 sine alpha is uy. So it's just the horizontal component is in the x direction and the vertical component is in the y direction. Now let's work out what cos alpha and sine alpha are. So if tan alpha is 3/4, we can work this out using a little sketch here of a triangle. There's alpha. We know that tan is opposite over adjacent, so the opposite side here is 3, the adjacent side is 4, which means the hypotenuse is 5. So we know from that that cos alpha, which is adjacent over hypotenuse, is 4/5, and sine alpha, which is opposite over hypotenuse, is 3/5. So I didn't even need to work out the angle alpha there, I can just get them straight off from that diagram. So my horizontal component is 40 times by cos alpha, which is 4/5. And my vertical component is 40 times by 3/5, because that's sine alpha. 40 over 5 is 8, times 4 is 32. 40 over 5 is 8, times 3 is 24. So my horizontal component of the speed is 32 meters per second, and my vertical component of the speed is 24. And together, the pair of them, let me show you something clever here. Imagine it like Pythagoras with a horizontal and a vertical at right angles to each other. 32 squared plus 24 squared, and then square rooted gives us the initial speed of 40. So we can see what's going on now. We've got to express our initial velocity as a vector u. I've already done that, 32, 24, but the question actually asks me to do it using ij notation. So it's 32i plus 24j. Now, very briefly then, example 5. Oh, do you know what? I've not written example 5 down. Let's do it here now. So example 5, we are told that a particle is projected with velocity capital U, where capital U is 3i plus 5j. I have a feeling I wrote this down. Have I put them out of order? Aha, I have. I've got it. Here we go. Did look very familiar. Here we go, 3i plus 5j. We've got to find the initial speed of this projection and the angle of projection. So let's sketch this vector, shall we? Oh, let's pick another colour. We'll go for green this time. So 3i looks like that. And 5j looks like that. The angle is alpha. The initial speed is the magnitude of this vector u here. So the initial speed is the magnitude of the vector u. So we're going to apply Pythagoras to this. So the square root of 3 squared plus 5 squared. So 3 squared plus 5 squared is 34. Root 34 is the exact answer, or we could round it to 5.83. So let's stick with root 34 metres per second, or approximately 5.83 metres per second to 3 significant figures. Now, the angle alpha is given by this. Tan alpha is opposite over adjacent, 5/3. Therefore, alpha is inverse tan of 5/3, and inverse tan of 5/3 is 59.0 degrees. Now you can have a go at exercise 6b.